What's up everybody, this is Wallace from A3Academy, and today we're going to be talking about the chi-square test. Now when we're using the chi-square test in an experiment, we're pretty much asking of the experiment, do the results show correlation between the two variables that we're trying to compare in the experiment? So what I mean by that is, suppose we had an experiment where we had, say, 200 people, and out of these 200 people there were 50 in each age group. And we asked everybody in all four age groups, do you like z-donks? Now, if you didn't know what a z-donk is, it's just a cross between a zebra and a donkey, and it's pretty much the official animal of A3Academy by this point. So, you've pretty much gotta love z-donks. But anyway, suppose we ask that question to everybody in this group, and everybody out of these 200 people has to answer either yes, like they do like z-donks, or no, like they don't like z-donks. Now, the reason we're separating people into different age groups is because we're trying to see whether the age of someone affects whether or not they like z-donks. So we're trying to figure out the answer to this essential question. Does age impact z-donk preference? And the two things we're trying to compare are age, how old someone is, and their z-donk preference, or whether or not they like z-donks. And so these are the two things we're trying to figure out whether there's a correlation between age and z-donk preference. So we're going to use the data that we collect from this experiment and the chi-square test to find out whether there's a correlation between these two. Now for every experiment like this, we need to first find out what the null hypothesis is. And the null hypothesis basically says that there is no correlation between the two variables we're trying to compare in this experiment. So the null hypothesis is basically there is no correlation between how old you are and whether or not you like z-donks, or age does not affect z-donk preference. Now this null hypothesis may be true and it may not be true, and we're going to find out using our results from the experiment and with the chi-square test. So first of all, suppose we conduct the experiment and we get this data here. And so on the left column we have the age group that we're trying to survey, and on the right we have the amount of people in that age group that answered yes to the question, do you like z-donks? And the way we're going to find out whether there is a correlation between how old you are and whether you like z-donks, we're going to use what's called the Pearson chi-square test, or just the chi-square test. And in the chi-square test, you first calculate the chi-square statistic, which will help you find out whether the null hypothesis is true or not. So remember we said our null hypothesis was that age does not affect z-donk preference. Now, suppose we assumed that the null hypothesis was correct and age does not affect z-donk preference, then the same amount of people should be answering yes to the question, do you like z-donks, regardless of how old they were. So the ideal values of this experiment, if the null hypothesis was true, were if the same amount of people in each age group answered yes to the question. So we can get this by just averaging the four results that we got from the actual values, and that would be our expected value for all four. So for each age group, 36 is the number of people you'd expect to answer yes to the question, if the null hypothesis were true. So let's make a table of the list of the age groups, the actual responses we got, and the expected ones we would get if the null hypothesis were true. Now you can calculate the chi-square statistic in part using this equation, actual minus expected squared all over expected. So if we used our table and we calculated actual minus expected squared all over expected for each category, and we added up all these numbers, we would get 1.55, which is the chi-square statistic. Now we need to find something else called the critical value, and we can find the critical value by using this table here. To find the critical value, first you need to know the p-value. Usually people use a p-value of 0.05, so we're going to use that in our experiment here. P equals 0.05. Then we need to find the amount of degrees of freedom. The degrees of freedom is just the amount of categories. Here we have 4 categories, 1 for each age group, and we take the number of categories and subtract 1. So we have 4 categories minus 1, that's 3. So that's the amount of degrees of freedom we have. That's our critical value. And now it's just a matter of taking our chi-square statistic that we calculated to be 1.55 and our critical value, and that's 7.815. Now notice that the chi-square statistic is a lot smaller, which means that we have to accept the null hypothesis is true. Remember we said that the null hypothesis was that age does not affect z-donk preference. That's true. So from this experiment, we have determined that age does not affect z-donk preference. So how old you are, whether you like z-donks, those two things are not related. Now suppose we had a big chi-square statistic, like 15.5. In that case, the chi-square statistic would be a lot bigger than the critical value. Therefore, we would have to reject the null hypothesis. So remember, our null hypothesis was age does not affect z-dunk preference. We would have to say that's false. Age does affect z-dunk preference, and whether you like z-dunks depends on how old you are. So the 6 major steps of the chi-square process. First thing you need to do is determine the null hypothesis. There is no correlation between the two variables you're trying to compare. Second, you need to find the expected values for your variables if you assume that the null hypothesis is true. So what would you expect the different values in your categories to be if the null hypothesis was true? Third, you need to find the chi-square statistic. You can do that by using that formula that we showed, actual minus expected squared all over expected, and then you add up all the values for the different categories. 4, you need to find the amount of degrees of freedom. That's just the amount of categories minus 1. 5, you need to find the chi-square critical value. You can find that just by taking a look at the table, finding your p-value and your degrees of freedom, and then finding out on the table what your critical value is. Now that you know your chi-square statistic and your chi-square critical value, you can accept or reject the null hypothesis. And now that you know how to perform the chi-square process, that's all for today. I'm Wallace from A3Academy. I'm hoping that you learned something, and as always, the more you know, the better you are.